Hello, pre-algebra. Mr. Lawrence here with your flipped lesson for Wednesday, February 22nd. And this lesson is all going to be about surface area. Yes, that's right, surface area. And remember, surface area is like saying the amount of plastic it takes to make a Coke bottle, the amount of metal it takes to make a can of pop or peaches, the skin that it takes to cover your body, the amount of paint it would take to paint a box. Okay, it's all surface area. It's area of surface. All you have to be able to do is to break a shape down into its polygons, a three-dimensional shape, break it down into its polygons or circles, then surface area becomes super duper simple. For example, let's see if I can do this. Oh, it doesn't give me a hexagon in here. Oh yes, it does. There we go. Okay, so I have this hexagon, all right? And, oops. Okay, let's say I had this hexagonal prism here. Remember, it's a hexagon because the bases are both hexagons, right? Now, some of you can see the hexagons pretty simply. In fact, you see them, and I'm going to highlight them. There's a hexagon here, right? And then a congruent hexagon is down at the bottom, right here, right? Let's say that in this problem, they told you the area of the hexagons is hexagon here. The area of the hexagons, they just tell you this because we're not going to spend the time figuring out the area of the hexagon, is, I don't know, say 100 meters squared. Okay. They also tell you that the prism here is 30 meters tall. It's a very large prism. And we're going to make this a regular hexagon, and we'll make all these sides the same length. Okay. And so I'll label this one here, and we'll call it 5 meters. All right. Well, you know that there are two hexagons. So you're going to need 100 written down twice, or 200, right? I'm going to go ahead and, oh dear. I'm going to go ahead and write down 100 two times. Okay. Now, a lot of you have trouble seeing what else makes up the shape. You know that there are two hexagons, that you have no doubt, but you're not sure how many rectangles there are. Well, if you know the base is a hexagon, then there are 6 rectangles. How do I know? There's one coming off of each face. There's one coming off of each face. Yeah, exactly. So there's 2 hexagons, but then there's 6 rectangles. So the rectangles might look something like this. Okay, and there'd be 6 of them, right? So 2, 3, 4, 5, and 6. All right, well, now I just have to figure out what are the measurements. Well, I know they're each 30 meters tall. I know that because it's given there. Let me infinitely clone that. So they're each 30 meters, right? Okay. And remember, I said the hexagon was regular, which means each one of these marks here are the same. So one of those bases is 5 meters. That means they're all 5 meters. So let me label them all, and I'll use my smartboard. Now, it won't always be this way. It's only because the hexagon is regular. All right. Well, let's say here, we're going to calculate the area of one of these. Well, base times height would be 30 meters times 5 meters would be 150 meters squared. Well, if that's the area of one, and they're all congruent to the area, to each other, then they all have that area. So now, all I have to do is add up all the areas all together. Now remember, I already had the 200s. I guess I could clone this one and write it down here. But I have the 200s, and then I have 156 different times. So I have 100, 100, 150, 150, 150, 150, What is that? 4, 150, and 150. All right, so I'm going to add all those together. 5, 10, 15, 20, 25, 30. 0 carry the 3. 1, 2, 3, 4, 5, 6, 7, 8 plus 3 is 11. The surface area would be 1,100 meters square. It's that simple. You just got to be able to break it down into its shapes. All right, I'm going to give you another shape and see what you can do with that. Hold on one second. Okay, let's say I have this triangular prism. Remember, the bases are going to be the triangles, and I'll highlight them. They're parallel to each other. That's how I know they're the bases. Okay. All right, there we go. And so they're the two congruent bases. So I'm going to draw those two triangles, okay? And I know that they're isosceles triangles. They kind of look something like this. Now I know that from the picture of the prism, the side is 10 inches. I know this side is 20 inches. Now, ask yourself, do you know the height of this prism? Well, the height of the triangle. I do know it if I look back at the prism, but the height is not 20 inches because this angle right here is not 90 degrees. Remember, base and height always form a right angle. The height of this triangle would be from the highest point to the lowest point at a right angle. And according to the information over here, that is going to be 17.3 inches. So I'm going to kind of go like this, 17.3 inches. Okay, and I do know there are two of those triangles. So I'm going to do the base times the height, and then I'm going to cut it in half. That'll be the area of one of the triangles, and then I'll double it. Well, there's my right angle, so the base is going to be 10. The height of that triangle is 17.3, and those are being multiplied, and then I'm dividing it by 2. All right, I can go like that and turn that into 5, and I'll get an answer 5, 6, I think 86.5. Let me just confirm that so I don't make any silly mistakes. 10 times 17.3 divided by 2, 86.5. Yeah, and there's two of those. So I'm going to write down 86.5 and 86.5. Now, it's a triangular prism, and if you were listening to the previous problem, you know that there's going to be 3 rectangles. All right, so I'm going to draw 3 rectangles, and I'm going to label them. So there's one of the rectangles, there's a second rectangle, and there's a third rectangle. Now, I'll decide if any of these rectangles are congruent. If they are, great, I'll have less work to do, but if they're not, I'll have to find the area of all 3. I'll still find the area of all 3, but if some are congruent, I'll just be able to write it down. Okay, now I'm going to get rid of this highlighting and see if you can see some of the other areas that are highlighted. The first rectangle that's jumping out at me is the bottom rectangle where this prism is sitting. See it there on the bottom? Okay. That is a 10 by 23 rectangle. So I'm going to label this 10 by 23, and it's inches. And that, of course, would be 230 inches squared. Okay, I'm going to move this out of my way and show you the next rectangle I'm talking about. This rectangle will be this back one here. Okay, do you see it? I might have to scroll up a little bit. Okay, that backed rectangle there. Yeah, okay. Now, let me see here. Do I know that side of it? Yeah, I think that's 20, right? So one side of this rectangle will have to be 20 inches. And then I'm going to go back up and ask myself, do I know this side? Yeah, I think that's 23. So the other one is 23 inches. Okay. Multiplying 20 inches by 23 inches is going to give me 460 inches squared. Right? Okay. So now I've got to find another rectangle. Because remember, a triangular prism is going to have 3 rectangles. All right, let me find a different color here. There's a good color. And let me scroll so I can see my whole prism. Looks like the only one I haven't done yet is this front one here. Right? And so I'm going to ask myself, well, this green side I've already highlighted up here. That's 23 inches. So this is 23 inches. And now, if I could know the other side, meaning this back one, well, that's going to be the same as this, which is 20 inches. So it turns out that the rectangle I did in that light blue color and the rectangle I did in the green are actually congruent to each other, so I don't need to recalculate. I just know it's going to be 460 inches squared. So now I've got 86.5 and 86.5, and then I have 230. And notice how careful I am to line up my decimal points. 230, the decimal point would be there. I'm going to put a 0 there as a placeholder. Oops, I should get rid of that underline. I'm not ready to underline yet. And then I'm going to have 460 show up twice. And I'll put 0.0 just to line my work up so I don't make any silly mistakes. All right, so now I'm ready to add. And let me scroll that down. 5 and 5 makes 10. That's going to end in 0. I'm going to carry the 1. 12 and 1 is 13. I'll carry that 1. It looks like I got 14, and then 14 more is 28, and 28 and 4 is 32. And I'll carry the 3. 4, 8, 10, and 3 is 13. It looks like my surface area of this triangular prism is 1,323 inches squared. And there you go. It's that simple. Break it up into its shapes, find the area of all the shapes, add them all together. That is surface area. All right, Mr. Lawrence signing off. We're going to get some practice with this tomorrow in class. Have a good night, everybody.